presenting.
Thank you for everyone, and my name is Dr. Woo, and today I will present the related methodology, and I will present as entitled of the reliable design of the mechanical system subject to defective stress. This reliable methodology will improve the product reliability. I will also provide two case of study. As seen in the slide, we know the automobile consists of multiple of the modules, engine and transmission, drive and electric and the body system. And the automobile consists of 22,000 pieces. Life target is B20 like 10 years. To improve the performance of the reduced cost, products will be designed yearly. By reliable testing, engineers should find the design flow of the product module. This is a refrigerator. It also consists of the multiple of the module. Therefore, refrigerator part is 2,000 pieces. Life target is B20, life 10 years. Generally, product reliability can define the ability of the item to perform the required function under the state, environment, operating condition for specified and over time. Therefore, the product reliability can be described as a best of. If a product follows the best of, it will be rejected the marketplace because of it has an initial failure rate, higher failure rate, short lifetime. So companies that improve the design and faster will be changing in the straight line. The reliability they can achieve without the design failure. This slide shows the failure mechanism and the product design. And repeatedly the load is applied the product structure. There is a design flow. The structure will be collapsed and in life types to prevent them. Design for flow is must found before the product launching. The issue is how to find the product flow and the layer probability. The solution is reliability testing under the accelerated testing. This slide shows the solid state diffusion impurity, including void and the hole in silicon. It takes place at the electromigration induced void, build up the chlorine ion, trapping on the electron hole. And if I apply the electric field, and the barrier distorted and shifted, and the junction function and the model and the sine hyperbolic and the exponential function. If I take inverse and the junction function, we can find the general stress model. As you can see the slide, and the sine hyperbolic is the increased linear and power state stress and exponential. Usually at the accelerated testing takes place in the medium state stress range, and the power is m power over stress. Finally, we can find of the accelerated factor, the ratio of the stress and the exponential and the temperature difference. Power in the the power system is can define and define as a product effort and flow. For example, mechanical train generation effort is a force, flow is a velocity. Most of the stress come from the effort, and finally we can find the time to failure is can define of the effort, and finally, we can redefine the accelerated factor and the ratio of the effort and the temperature difference. I will explain how to derive the sample size equation. Product follow the Weibull distribution. Life function is defined as and characteristic life and the shape of parameter. If I take the logarithm, we can find the px life. At this equation, we don't know the characteristic life and can define and testing data. And then we can summarize and the px life looks like that. As you can see that this slide, this is the equation is very complex and the chi-square distribution and the logarithmic. And the sample size equation is approximated, can approximate it. There are two approximations. One is a chi-square approximation, and another is a logarithmic approximation. And the confidence is less than 60%, R is less than 4, and the chi-square distribution R plus 1. And the logarithmic is cumulative failure less than 20% in the approximate X. We rearranging and we combine the sample size equation. I will show the one of the case study. This is a refrigerator, and this is a compressor with redesigned crankshaft. There is a lot of parts, and because there is an unknown design port in the compressor system, compressor lifetime depends on the parametric part. To find them, it requires the lifetime methodology. This is a parametric design schematic. Compressor is low is increased pressure and low and higher. We don't know how to use the customer use, but we have to design and the compressor and the robustly. This related methodology consists of the failure ratio of return product, parametric art, design modification, finally checking and product achieving lifetime goal. This is the damaged compressor, and we found the wear due to the lubrication problem in field. It came from the improper of the design of the structure. To modify it, reproduced by parametric art and collected them. This is a load analysis for the Excel analysis, and this is a refrigerator cycle. It consists of the compressor, condenser, coupling tube, evaporator. From the conservation of mass in coupling tube, energy balance, condenser, and evaporator, we can determine mass flow rate, temperature, condenser, and the evaporator. And from the time to failure, we can find the stress came from the pressure difference. I will tell you how to calculate the accelerator factor. And accelerator factor is determined by the ratio of pressure difference and the temperature difference. And for the worst of the case, pressure difference is 1.7. For accelerated testing, and the increased pressure is 1.9. And the accelerated factor is 3.4. And the worst case of dome temperature is 19, accelerated 120. And calculator's accelerated factor is 1.4. Totally, the accelerated factor is 4.6. By applying a duty cycle, and we can search out the design failure. I will tell you how to calculate the mission cycle. And the lifetime of the domestic compressor is beyond life 10 years. Accelerated factor is 4.6. Total sample size is the domestic compressor is 100. Compressor lifetime is almost 87,000 cycles. There is no problem, 19,000 cycles. We can guarantee the compressor lifetime is beyond life 10 years. This is a parametric art equipment user equipment. It consists of test jig, and we can proceed the parametric art with the equipment. I will tell you the result of the first art the result. And in the first art is a compressor lock due to the lubrication and 7,000 and 10,000 cycle. And it came from the severe wears came from lubrication problem. And the pattern of the first art and the first art is very similar to that of the field. By parameter alter, we can reproduce the compressor failure in field. The crankshaft wear is in first alter came from the no lubrication region, no starting and RPM, and the material of the compressor shaft. As an action plan, we redesigned and the crankshaft and changing of the dimension, adding in the new groove, and changing in material. And by parametric alter, we can collect the compressor failure. This is a second the alter, the crankshaft wheels found at the 90,000 cycle. It came from the between of the crankshaft and the slot washer due to the narrows at the clearance. Therefore, we redesigned of the dimension and by parametric alter we can modify the design port of the compressor. This is a summary of the parametric alter. In the first alter, we found of the lubrication problem from the crankshaft. In second alter, also we found the wear. We changing and the clearance between the washer and the crankshaft. And after the modification of the design flow, and there is no problem, and 19,000 cycle and 20,000 cycle. Compressor achieved the lifetime target beyond life 10 years. I will give you another case study. This is a refrigerator and one of the system of the hinge kit system. It consists of a lot of the different parts. One is a hinge cover, oil damper, and the housing. There are design of the design port in hinge kit system. We don't know which part is. Hinge kit system lifetime depend on the design port of the part. To find them, require the new relight methodology. And this is a parameter design schematic, and hinge kit system designed to the comfortability to close and the refrigerator door system by pushing by hand. In design, we don't know how to using and the customer using. We have to design and robust each part. And to achieve the goal of the product design, the reliability require the failure analysis and parameter alter the design modification, finally the checking lifetime, it is achieved. This slide shows the damaged product in field. And there are a lot of the crack and on the hinge kit system housing, it came from the fragile structure and design port. By reproducing and parameter alter, we can collect them. This is a load analysis for external light testing. And normally hinge kit system is subject to the door weight. Because to the increase of the impact of the hinge kit system, we added additional accelerator weight. Because of the time of the failure depend on the impact force, we can control the impact and carry out the accelerator testing. I will tell you how to calculate of the accelerator factor, and for worst of the case, the impact is 1.1. For accelerator testing, 2.7, and the calculated accelerator factor is 6.3. By applying to this cycle hinge kit system, we can search out the design failure. I will tell you how to calculate the mission cycle. Lifetime target is a hinge kit system beyond life 10 years. Accelerator factor is 6.3. Total sample size is 6. And hinge kit lifetime for 10 years and 36,000 cycle. There is no problem in the 41,000 cycle. We guarantee the lifetime target hinge kit system beyond life 10 years. This is equipment using in the accelerator testing, and it consists of the test jigger and the controller. We can proceed the parametric art with the equipment. I will tell you the first result of the parametric art. Hinge kit housing of the hinge kit system is collect 3,000 cycle, 50,000 cycle. The pattern of the first the art is that the crack is very similar to the in the field situation. By the parametric art, we can reproduce the design flow hinge kit system. I will explain how to improve the design of the hinge kit system, because the hinge kit system is a first art came from the fragile and fragile structure. And we are the weaker structure, the hinge kit system, and in the outside, we eliminate and notch and give it to the rounding. And we also keep it the rounding inside, rounded. And then we gave to the rounding and the reinforced rib and the house and the deck. After first part, we deassembled the hinge kit system. We found the leaked oil damp. The root cause of the this failure came from the oil damp sealing structure. When operating and the oil damp hinge kit system, both oiling is the interfere of the Teflon, and finally that the oiling tears and damp is leaks. Finally, we modify the oil damp sealing structure. By parametric art, we can reproduce the design fault of the oil damp. I will tell you second at the result of first parametric art at the housing the cover the hinge kit collect 7,000 cycle, 9,000 cycle, and the root cause came from the material, and when operating hinge kit system and oil damper spotter, strike and housing cover. And finally, housing cover is a flexor, and then the hinge cover housing is changing and material and plastic and to the aluminum die casting. By the parametric art, we can modify the fragile and the housing cover of the hinge kit system. This is a summary of the parametric art result. The first art we found is the two-part problem and the housing and the oil damper. In the second art, we founding and the hinge kit cover. We change the material. After modify and design the specification, and there is no problem. 41,000 cycle, 74,000 cycle. This is my